This conference will now be recorded.
All right, guys. Good morning and good evening to everyone. So today we'll discuss something called Kubernetes. Kubernetes is a container orchestration program. All right. So what we'll try to understand what is orchestration first. Then we'll try to discuss about Kubernetes. Okay. Today's today's agenda is like the theory part. Okay. How exactly Kubernetes is going to work and how it is helping us to group the individually running containers. I hope you are able to see my screen and my voice is clear. All right. Kubernetes also called as K8s. Okay, let me write it down. K8s. Okay, Kubernetes is also called as K8s in real time. Why K8s? Because the alphabets, okay, the alphabets or the letters between K and S, the number is 8. Okay, so if someone asks what is K8s, then tell them that it is nothing but Kubernetes, that is a container orchestration tool. Okay, so in interviews and all, they'll use these shortcuts K8s and all. All right, so Kubernetes originated from Google. Okay, Google is the inventor of Kubernetes, and now Google made this Kubernetes program as open source, which means that anyone can download the source code of Kubernetes. They can customize it, they can modify it, and they can change the source code according to their project or company's requirements. Okay, so Kubernetes is a container orchestration technology. What is orchestration in general? In English, what is orchestration? Orchestration is nothing but grouping something. Okay, so grouping, or we can say orchestration means arranging, or we can say coordinating. Okay, so here what exactly we are trying to group, we are trying to make a group of individually running containers into one single entity. Okay, so whatever the content, until now we have discussed Docker containers, right? In Docker tool we have discussed containers. So these containers were running individually. There was no link between one container and the other container, right? Now whatever we are going to do now from here onwards in Kubernetes, all these containers are going to be grouped together in one single group, and we are going to treat this group as one single entity. So whatever the changes we apply to that group, all the changes will be applied to the all the containers which are inside that group. Okay, so there is a technical term for that group. Okay, we are going to call it as a pod. We'll discuss more about pod in coming few slides. All right, so we have already discussed what is a container, right? So Docker container is nothing but it's a lightweighted standalone executable package of software that includes everything which we need to run and test an application, right? So a Docker container contains everything: a code, a runtime environment to test the applications, system tools, editor to edit the files. Everything is there inside a Docker container, right? So here we are trying to orchestrate these containers. Okay, so let's take an example. See, you're trying to launch one web application website. Okay, so for launching one website for web application, you need what? You need let's take a Docker container, which is hosting an Nginx website. Okay, Nginx or HTTPD, or you can also use Apache to anything. Okay, so a Docker container which is hosting a web application. See, a container is hosting a web application, good, but what about the details, like user data, their credentials, their account details, everything? We need to store their details in some other place, right? In a separate container, and that container is called as database container, right? So database container. So the first container is going to host the website web application, and the second container is going to host the database, which includes everything like credentials, user information, their transactions, everything, right? So these two work together to create one single web application, right? Once these two are working together, only then a website will run successfully. right? So this is what we are going to orchestrate. Two or more applications we are going to, two or more containers we are going to uh, uh, group together to make it a single application to work. All right. So that is what a container orchestration means. Okay, got an idea? Now, okay, what we're going to discuss is so grouping of multiple containers. Okay, so we can manage them. We are going to manage them, and we are going to treat them as one single entity is called as container orchestration. So far we have discussed. So far we have launched different containers, right? We have launched Apache Tomcat container in project. We have launched various HTTPD Nginx containers in the Docker classes, right? So we are going to combine all of them in these Kubernetes classes, and we are going to check them. All right. So we are going to discuss some advantages of Kubernetes. So Kubernetes will create containers, and it is going to deploy applications inside that containers. And in order to manage those containers, we're going to use Kubernetes. And remember one point, we can launch, we can launch more than two containers. We can launch any number of containers. At least two or hundred or thousands of containers can be launched with the help of Kubernetes. Okay, so whatever the disadvantages which we were facing in Docker, all those disadvantages or all those drawbacks has been addressed by the Kubernetes. Okay, and what are those drawbacks? We're going to see in the next slide. So anyway, Docker is a very advanced tool, and it is used by number of people, millions of people all over the world. It's a super hit, and it has its own issues. Like there are some disadvantages and all those disadvantages like auto healing, downtime, all those things has been addressed by Kubernetes. So we'll see some of the features of Kubernetes. But before that, you need to understand that Kubernetes runs on any environment. Like it runs on virtual, or it runs on physical machine, or either, and even it runs on cloud machines like EC2 instances and all. All right. Now, Kubernetes was launched by, it was invented by Google. It was originated by Google, right? So they have given some preference. It works very well on GCP more. GCP means what? Google Cloud Provider. Okay, so GCP means this is a cloud platform, same like AWS and Azure, but it is developed by Google. Okay, so Kubernetes supports all the major three platforms: AWS, Azure, GCP, and all other platforms as well. But in GCP, it has more advantages. Okay, so got an idea, right? So container orchestration means like we are trying to group all the individual running containers, and we are trying to treat them as one single group or entity. There are like many platforms in the market. Some of them are Kubernetes. We have Docker Swarm. This is another alternative for Kubernetes. So once Kubernetes became a hit, Docker realized that this container orchestration technology is very much important, and Docker Corporation have launched their own orchestration technology, which we call it as Docker Swarm. Okay, this is an additional. This is the next level of Docker tool. And apart from this, we have OpenShift. OpenShift, it is developed by Red Hat company. Okay, Red Hat. Now Red Hat is a part of IBM, right? Hat, Red Hat has been acquired by IBM. So OpenShift, we can call it as it is a tool from IBM. And apart from that, we have Apache Mesos. Okay, Mesos. This is a container orchestration technology from Apache Foundation. All right. Features of Kubernetes. Okay, some of the important things which we need to understand why exactly the Kubernetes is required. So what are the things which were missing in Docker? All those things has been addressed by the Kubernetes. See, I have been talking about Docker, containers, Kubernetes, right? So by now you should have you should have got an idea that Kubernetes manages the containers. So indirectly, I can say that Docker is the prerequisite of Kubernetes. In order to work with Kubernetes first, we should learn Docker first. Okay, and in order to launch or set up the Kubernetes lab, we should first set up Docker first. Okay, so Docker is the prerequisite for Kubernetes. All right, so the first important feature of Kubernetes is orchestration, right? So earlier we used to run Docker containers individually. Now we are going to group them and we are going to call this process as orchestration. The Docker containers might be running on different platforms, whether it can be in different hardware, like whether it can be on-premise servers or it can be a virtual servers or it can be a AWS cloud instances as well. The next important feature is auto scaling. In Docker, by default, the auto scaling concept is not present. Okay, meaning if the load on one particular container is more, the container cannot bear that additional load, and what will happen? The container may crash, right? If the, for example, see, you have hosted one website on a Docker container, and the number of people, the number of customers or users who are trying to visit that web application is increasing. What will happen? Obviously the container will not be able to handle that type of load, and the container will crash automatically. The website will be going down and it will be leading to the customer's dissatisfaction. So in order to balance the load, we need additional containers based on the additional load, right? So in order to turn this, in order to make this happen, we need something called auto scaling, right? The same auto scaling concept which we have discussed in AWS, the same auto scaling concept here we are going to achieve with the help of Kubernetes. Okay, so more containers, more load can be handled. The next important point is auto healing. Okay, what do you mean by auto healing? Auto healing is nothing but, let's say that you have three containers and one of the container have crashed because of some reasons, like there are some technical reasons. One of the container has crashed, and what will happen? Kubernetes will come into effect. It will try to take some action. It will try to rectify the failed container. By doing what? It will try to restart the container. It will try to assess the container, analyze the container, what exactly has went wrong. It will try to check the application. It will try to restart that service. If it works well, or it or else what it will do, it will launch a new replacement container in place of the crashed container. Okay, so Kubernetes will try to rectify what exactly has went wrong. It will try to rectify the application, try to restart the service and all. If that works out well, okay, or else it will try to replace that crashed container with the help of a new one. That is called auto healing. Okay, so the next point is load balancing. So we connect load balancer and we distribute the load across all the containers. In Kubernetes, we can set up a load balancer. We can distribute the load across all the containers equally, so that what will happen? We can minimize the additional load, or we can minimize the excessive load on one single container, and we can minimize the containers getting crashed down. Okay, so setting up load balancer can be achieved by Kubernetes, and what we can do is, like, we can equally distribute the load across all the containers, which will lead to less failures of containers. Okay, the next one is platform independent Kubernetes. Whether you launch the containers on, as I told you earlier, we can launch containers running on any machines, like based on machines running on physical servers, right, on-premise servers which we can touch, right? Or servers which are like virtual servers, like VM machines, VMware machines, Oracle VirtualBox machines and all. Or also we can call it as cloud servers, EC2 instances, Azure servers, anything. All right, so anything can, in anywhere the containers which are running Kubernetes can be set up. We can manage those containers. The next one is fault tolerance. So in order to understand this fault tolerance, first we need to understand a technical term called pod. Okay, so first Just try to understand. Okay, let me explain pod later. But just understand that Kubernetes will launch new containers in case of any fault failed containers. Okay, so pods are nothing but, pods are nothing but pod is a, see, this is like a box. Okay, inside this we can launch multiple containers. Okay, these all are containers. Now this box is there, right? This outside box, this is the, this is what we call it as pod. Okay, so in technical terms, how can we define pod? Pod is nothing but, pod is an abstraction of a Docker container. Okay, so it is nothing but, it is the running environment. Pod is nothing but a, it creates a running environment for a Docker container to run. Okay, so that, in case the Docker container fails, you will have that abstract, the Docker containers abstract will be there, and you will be able to replicate the setup easily. Okay, so with the help of pod, you are no longer going to work with Docker containers directly. First you are going to deal with pod. So what are the changes you apply to this pod? All those changes will be applied to all the containers which are present inside it. Okay, so coming to this point, doc using Kubernetes, we are going to minimize the pod failures. Okay, pod failures. The next one is rollback. Okay, rollback. So here also in Kubernetes, here also we are going to write some code. Okay, code in which language? Code in YAML. Yeah, the same famous YAML. Okay, Ansible, Docker Compose, and again in Kubernetes we are going to use YAML. Okay, either we can write in YAML or we can write it in, JSON. Okay, anything, it's up to you. In whichever language you are you're good with, you can write it down. That's it. That's up to you. All right. So in Kubernetes, we are going to write some code, and we are going to write the YAML code, and we are going to create a file. What do you mean by, I mean, what is the name of this file? The file is called as manifest file. Manifest. Okay, manifest. This the same manifest file. Okay, so in Ansible, what we have playbooks, right? So in this here also, we are going to create a file, and that file name is called as manifest file. All right, or also it is also called as user request file. Okay, what are the request, what are the need we have, what are the changes we want to see in Kubernetes setup, that all those requests are going to be placed inside this file. So whatever the code, we are going to write it down. Okay, we are going to execute that code, and that code is going to be converted into Kubernetes infrastructure. Okay, so very similar to Ansible. Since uh, we are going to write the code, we are going to, what we can do, we can store that code in the GitHub, right? We can apply version controlling, right? So what we are going to do, we are going to use, for example, okay, if you need it, you can install Git, you can apply version controlling. I mean, you can commit the files, you can create different versions of the files. All right, so whenever there is a change, and whenever you feel that the new current version is not working, the new current Kubernetes version is not working, if you want to roll back to the previous version, if you want to roll back to the previous setup, what you can do, you can use the previous committed file. Okay, use the previous committed file, and all the previous changes will be brought back to the Kubernetes setup. Okay, so that is what rollback means. You can apply version controlling, and what are the changes you want to see again, the old changes, you can bring back those changes easily. All right, and one last point is high availability. Okay, Kubernetes offers high availability of the Docker containers, which means that Kubernetes makes sure that the containers doesn't go down so easily. Okay, Kubernetes will try to see that containers are highly available, and the downtime is minimized. Okay, that is one more important point. Let me write it down here. Okay, All right, clear, right? Clear so far? All right. If you have any doubts, ask. Okay, so this is the Kubernetes setup. Something it looks like something like this. Okay, so Kubernetes also it is also again same master and slave setup, master and agent setup. We have one server which is going to act as Kubernetes master, and the other machines are going to act as slaves, or we can call it as nodes or agents, anything. Okay, so same like Ansible, same like Jenkins, we have Kubernetes master and slave setup. Okay, so in the middle one, the blue color one is the Kubernetes master as per our diagram, and the other three right hand side machines are going to be called as nodes. In nodes, we are going to install Docker first. Okay, in nodes, we are going to install Docker first, because as I told you, Kubernetes controls the Docker containers. So here the Docker is the prerequisite. Okay, so we have to install Docker first so that we are going to launch containers. What are the containers you're launching? All those containers are going to be inside a pod. Okay, inside a pod. So pods and a pod, as I told you, pod is nothing but it's the abstraction layer of a Docker container. Okay, logical collection of a containers. Okay, you can see the definition here also. Pods are nothing but the logical collection of containers, which is nothing but an abstraction where we can create the Docker running environment. We can make sure that the containers can be run easily inside that pod. We can access the Kubernetes master in two ways, either by command line interface or by user interface. Okay, both are available. So if you want to access Kubernetes master using user interface, we can access it. Okay, very beautiful user interface is available, same like Jenkins. We can control our setup using that user interface, or else in a typical manner as a DevOps engineer, it is always advised to go with the command line interface. Remember the commands and all. Okay, so Kubernetes doesn't know anything about container. It doesn't understand what is a container. Okay, it understands it just recognizes only pods. It knows only about pods. It doesn't know anything about containers. Even if you have one single container, that container should be inside a pod. Only then you can manage it. Okay, so remember that container should be always inside a pod. Only then you will be able to manage it using Kubernetes. So pods contains one or more containers, and we are going to manage them as we have discussed earlier. So pods are also you can see this point. Pods are atomic unit of deployment. Okay, atomic unit means which means that that is the smallest part of the Kubernetes setup. Okay, smallest part. It is the smallest unit which cannot be differentiated, which cannot be divided further. Okay, so as I told you, pod consists at least one container. One container should be there inside a pod. Only then pod can be created. Okay, if there are more than one, we can all the containers will be tightly coupled, which means that containers will be placed very closely together. Okay, in order to save the space and the system resources, the Kubernetes is going to place all the containers very tightly. Okay, now we'll see how Kubernetes is going to work. What are the different components present in Kubernetes? Okay, there are a lot of components, lot of means lot of components in Kubernetes, and we are going to discuss some of the important components first. These are the important components of a Kubernetes setup. Okay, etcd, API server, scheduler, control manager, all these things. We'll discuss all these things now by in a diagram which I have created by myself. Okay, all right, see this. This is the Kubernetes master. The top one is Kubernetes master. Okay, and the below one are nodes. Okay, nodes. This is node 1, node 2, node 3. Okay, in some technical, in some websites, in some technical, I mean in some places, in some websites, you can see these are called as worker nodes as well. Okay, workers or worker nodes as well. Okay, so different terms for these nodes. We'll try to understand these components in a diagram which I have created. Okay, see this. So the top one, this diagram is divided into two parts. Okay, so the top one, this is one part, this is one part. Okay, the above part, okay, the above one is Kubernetes master, and the below one is the Kubernetes node. All right, the first thing is node is also called as minion. Okay, not that movie minion. Okay, so node is also called as minion. Okay, this is another technical term for that node. Okay, remember this point. Now in master we have mainly four components: one, two, three, and four. These are the I mean there are many components, but these are the most important one which we have to first discuss. All right, as I told you, this is master and this is slave. Okay, or node, same like Ansible. So here we'll launch one server and we'll install Kubernetes master setup in this machine. Okay, only master package will be there, so that we have, in order to make this server as Kubernetes master, we have to download the master Kubernetes master setup. All right, let's say that we have taken one server, we have installed Kubernetes master setup, and our server is having all these components. Now the first thing what we do is we create a file. Okay, we create a file. Okay, we create a file. What is this file called? This file is called as user request file. User request file, also called as manifest file. Okay, manifest, remember that. We write this file in YAML language or JSON code. JSON or YAML, it's up to you. In whichever language you are whichever language you feel comfortable, you can follow it. We will give all the details, we'll give all the resource details. Resource details means how many containers should be launched, which image, Docker image has to be used, like Ubuntu, CentOS, Fedora, SUSE, Jenkins, Apache Tomcat. Whatever application you want to use, whatever Docker image you want to use, you have to mention here. How many pods are going to be created? In which pod, which container should go and settle down? Okay, what kind of ports has to be opened, what kind of volumes has to be mapped, what kind of services has to be running, all the things has to be mentioned inside this file. Okay, so this is a very important file. Okay, same in Docker we have Docker file. In Jenkins we have declarative pipeline, Groovy script. In Ansible we have playbook. In the same way, Kubernetes, this is an important file in which we are going to write a lot of code. All right, so this manifest file will be submitted to the Kube API server. Okay, we'll submit this file to the Kube API server. This is the first part. Okay, first component. Why exactly we are submitting it? Because you know what the things we have mentioned in this file, all those things will be executed by this Kubernetes server, and all those components will be created. Okay, all those, what are the information we have given, all those requests will be accepted and it will be created. Okay, so this is called as Kubernetes manifest file. All right, inside this server we have mainly four components. The first one is Kube API server. Kube API server, you know, it acts as a receptionist. Okay, it acts as the first part which accepts the file. It will check for the code. Okay, what are the syntax which we have given, what are the syntax is fine or not. If everything is looks good, Kube API server will accept that file, and it will uh, basically the purpose of Kube API server is to accept all the incoming requests from the users. Okay, it will receive all the incoming requests from the users, and it will act as a front end to the Kubernetes master. One second. Yeah, all right. So Kube API server acts as a front end of the Kubernetes master, which is responsible for accepting all the incoming requests which are created by us. Okay. So after taking the user request, what Kube API server will do, it will forward that request to the Kube scheduler. Okay, it will forward that request to the Kube uh, scheduler. Okay, so the file which has been received by this, it will be sent to the Kube API, sorry, Kube scheduler. Okay, Kube scheduler. So what is the action Kube scheduler is going to do? Kube scheduler is responsible for taking necessary actions or necessary steps. What are the instructions which we have given inside the file, which we have mentioned inside the manifest file? All those actions will be implemented. Okay, like for pod creation, package deployment, container details like image, ports, volumes, everything will be taken care by the Kube scheduler. So Kube scheduler will actually implement those changes to the node. Okay, so see this, it is going to implement those changes in here. Okay, so Kube scheduler is responsible for implementing the changes to the node. Now the next one is control manager. So these two are completed. Third one, control manager. See here, try to read this line: actual state equal to desired state. Okay, actual state is equal to desired. So control manager is responsible for maintaining the desired state. For example, if I want three pods to be running all the time 24/7, control manager will make sure that three pods are running. If any one of the pod goes down, control manager will come into effect. It will try to rectify, it will try to see that why one of the pod has gone down. It will try to restart that pod, it will try to restart the service and all. If that works out well, okay, or else it will create a replacement pod and it will try to match the desired state. Okay, so control manager will make sure that it will monitor all the pods. It will see that our desired state is matching. Okay, our actual, what are the actual state of Kubernetes setup is there, it is matching with our desired state. Okay, so that is a main action control manager which it is going to do. The next thing which we are going to discuss is etcd. Okay, the fourth one, etcd. So etcd is like a we also call etcd as cluster store. Okay, cluster store. So you remember Ansible? In Ansible, we had something called setup module. Setup module. I hope you remember it. What the setup module does, it collects the entire information and it stores that information, right? Of all the nodes, Ansible nodes. Here also, etcd, etcd does the same thing. It collects the entire information of nodes, okay, and it creates a database kind of storage, and it stores all the information related about all the master inside that database. Okay, inside that database. Okay, so that is why it is called as cluster store, because it stores all the information about the cluster, Kubernetes cluster and all. Okay, in which way it stores the information? It stores the information in the metadata value. Okay, in this way, key and value. Okay, in key and value format, it stores all the information. So if you want to know any information about the entire Kubernetes cluster, this whole setup, if you want to know the entire information, what is the details of master and what is the details of node and all, open this cluster store and you will be finding everything. Okay, so all these components which are running inside the Kubernetes will are responsible for maintaining the Kubernetes cluster. Okay. The next thing is, so these four processes, remember these four components. Okay, these are the most important four services which are running inside the Kubernetes master, and these are responsible for smooth functioning of this Kubernetes master. Okay. Now, coming down to the node, again in node also we have a lot of services, lot of components. Let's try to understand these main components. Okay, the first one is kubelet. Okay, now kubelet is the component or the service. This is responsible for listening to the master. It listens the instructions given by the Kubernetes master, and it does the changes inside this node. Okay, so what are the kube scheduler receives the request from the kube API server, the manifest file, and uh, what are the requirements which you have given inside this file. All those changes will be given to this kubelet, and kubelet will implement those changes. Okay, so it will pass on those details to the control container engine, the docker container engine, and the docker container engine will create the containers. Okay, it will create the containers, and it will create in such a way that a logical box, okay, a box will be created, and inside these containers will be created. If you have given two container setup, two containers will be created. If you have given three will be created. But you have to understand that at least one container should be created to make a pod. Okay, now we have something called kube proxy. Okay, kube proxy is the component, or it is the service in which it is responsible for assigning the IP addresses. Okay, so a pod can communicate with another pod. Okay, a pod can communicate with another pod only if, okay, only if both the pods have different IPs. Okay, and how the IPs are assigned? The IPs are assigned with the help of kube proxy. So kube proxy service is responsible for assigning the IP addresses to the pods. Okay, all right. So these are some of the important services which are available in the Kubernetes. There are some more services which we'll discuss as the classes goes on. Okay, so I hope this whole session gave you a basic idea how Kubernetes works, what are the different components and what are the different services, how exactly Kubernetes is going to help us in managing the Docker containers and all. Okay, any doubts so far? Okay, anyone else? Anyone has any other doubts? So we can understand Kubernetes much more clear. Cluster is nothing but the entire setup, Deepika. Okay, cluster is nothing but this whole setup. See this whole box. Cluster consists of master and nodes. Okay, the entire setup. Kubernetes cluster means the entire setup, which consists of master and nodes, different nodes. Okay, all right. So what we'll do is tomorrow we'll connect, we'll set up one lab, we'll try to see some practical sessions. Okay, how to launch nodes, how to set up pods and all, how to deploy some applications and all, we'll try to see with the help of some lab setup. Okay, so we'll connect back tomorrow at the same time, and we'll try to see the practical part. Okay, thank you guys, bye.